we are given a directed graph with n nodes we have given, which is 0 to n minus 1, and each node has at most one outgoing edge. And so we are saying that edge at I is j. It means there is an edge from I to j, right? If edge at I is equal to minus 1, it means I doesn't have any outgoing edge. It means no outgoing edge there. We are also given node 1 and node 2, and so our task is to find the node, right, that is reachable from both node 1 and node 2. We will do traverse from node 1 and we'll record the distance. We'll traverse from the node 2, we'll record the distance. So we have to record the distance, and after that we'll compare all the nodes that is reachable from both, and then we'll pick one. We'll create two distance array, distance 1 and distance 2, right, and we'll store the distance from node 1 and node 2, right, to all other nodes, and we'll fill them with the minus 1, that is we say as a unreachable initially. If it is minus 1, it means it will represent like that this is a unreachable nodes. And then we'll keep track of we can say we'll traverse for each nodes, right? We will traverse from each node. We'll use this loop. This is not the recursion loop, this is a simple loop to walk through the graph. And from a starting node, right, we have some starting node. From all the nodes will go, right, and we'll like node 1 and node 2 will go separately, and we'll mark them as a visited node, and we'll record the distance finally, right? Once we have recorded the distance here, right, we will return this finally, and we'll mark the visited road visited nodes, and we'll record in the distance and distance 1 and distance 2 that we have seen here, right? So distance 1 and distance 2 we have marked it. Now what we will do, we'll compare the distances for all the nodes. So for every node, right, we'll go for I 0 to n minus 1, means for every node I, right, we'll check if it is reachable from both node 1 and node 2, right? We'll compute the max distance, right? So we'll compute the max of distance at I, distance 1 at I and distance at I2, right? We'll represent this, right, from these two, which one is maximum, we'll store here. And we'll track the minimum distance, right? As you can see, we'll check the condition. If it is minimum, if it is greater than this, then this will represent that minimum will take, right? We'll track the minimum maximum distance, right, among all the valid nodes, and we'll track the one with the smallest maximum distance. And once you will find the smallest minimum one, right, there is a tie, we'll choose the node with the smallest index, and so we'll update this one. So this is your smallest index, and finally you will return it. If no common nodes is found, we'll return as -1. Otherwise we'll return the best node that we have found here, right?